So our last assignment or section for this unit or this half unit, we're on 2.9, using operations correctly. So just a couple of problems to do. This first one, we need to complete the table by filling in the mixing boxes. Write the operation in words, not symbols. The first line is just for an example. So the expression square root of 17, the object is 17, and what's happening to the 17? You're taking the square root of 17. So it's pretty basic, nothing too complicated. I think it's just thinking outside the box that's the hard part, and kind of interpreting what the problem is asking you to do. So let's do this second one. We have 4 and then 2/5. So the objects we're looking at are the 4 and the 2/5. How are they connected together? Like, what operation is being done to them? Even though you don't see an operation symbol, what's going on? We are adding these together. Like, you have 4 whole pizzas and then you have 2/5 of a pizza. You have 4 pizzas and then you're adding on the 2/5 of a remaining pizza. So you're adding those together. The next one, we have 8/9. We're looking specifically at the 8 and the 9. What's happening to the 8 and the 9? I think fraction, we should all know that that is division. The next one, we have the absolute value of -10. We're not given an object, but we know that the operation is the absolute value. So what's being absolute valued? It is the -10. Next, we have in parentheses, so -8, that whole quantity is being squared. We're looking at what are we squaring in this particular expression? We are squaring the -8, not to be confused with f, which is -8 squared. So what are we squaring in this one? Notice we had parentheses in the first one, no parentheses in the second one. We are actually just squaring the 8 in this one. And this is such a common mistake that I see students making, the difference between these two. If the negative is in parentheses, you're squaring it. If the negative is not in the parentheses, you do not square it. You'll see that come up on probably your review guide and probably your summative, maybe the cumulative exam, so be careful of that. Next one, we have 2 and then times the quantity x plus y. We're looking at multiplication. What is being multiplied here? Hopefully you know that parentheses indicate multiplication. So we have the 2 is being multiplied by everything in the parentheses, the x plus y. Then the next one, we have a plus b divided by 2. We're looking specifically at just a and b. What's happening with a and b? We are adding them together. And then same expression, a plus b divided by 2, but now we're looking at a plus b and 2. What operation is being performed on those two objects? We are dividing those two with a fraction division bar. J, we have a divided by 2 plus b divided by 2. So we're looking at what are we doing to a divided by 2 and b divided by 2. We are adding them together, thus the addition symbol. And then the last one, same expression, but we're looking at what specifically is being divided. We have 2 things actually being divided here. We have the a and the 2, and we have the b and the 2. So a divided by 2, b divided by 2. So there's 2 division operations in that expression. Okay, moving right along. Question number 2. Some notes if you need some help on these. And then the example at the bottom of page 218 is a great example of what we're specifically doing for question number 2. So take a look at that if you get confused by anything that I'm saying. So we need to simplify each expression. We have 7x plus 7 divided by 7. We want to simplify it if we can. So just like they talked about in the example here, it's pretty much the same thing except they used 4s and 1s. So if the operation, is divisible by 4 is being applied to the sum 4x plus 1, we can use the fact that division can be distributed over a sum to simplify. So what does that mean? I can really split this into two. Instead of one big fraction, I can split it up into two fractions with the same denominator. Okay? So 4x divided by 4 plus 1 divided by 4. Those are equivalent expressions. They're the same thing. And then from there, I'm able to reduce the 4's. So we're going to apply that same thing, that same idea to this first one. So we have the 7 as the denominator. So I'm going to split that into two fractions. So 7x divided by 7 plus 7 over 7. And then from there, hopefully you can see that you can simplify or reduce those 7's, and you'll be left with just x plus 1. Part B, I'm going to do the same thing. I have subtraction divided by 7. So I'm going to split it up into two different fractions, both with a denominator of 7, and I can reduce. I can't reduce that first fraction. There's nothing to reduce, but I can reduce 7 divided by 7 to x over 7 minus 1. And then I have same thing, except the whole fraction is negative, so negative x minus 7 divided by 7. Same thing. This time, I'm going to need to distribute that negative when I split my fractions up. So I have negative x over 7, and then instead of minus, for that minus 7, I need to distribute the negative, so it's actually plus 7 over 7. And then I can reduce that 7 over 7 into just 1. For number 3, are the following two expressions always equal? 2 over a plus b and 2 over a plus 2 over b. If they are, show why. If not, provide a counterexample. So we know that we can split up a fraction, same denominator. I can split it up into two different fractions. If I have like kind of the reciprocal, does it work if I split the fraction and just keep the numerator the same? Now, for counterexamples, you just need one thing to disprove a claim. So one example is enough to say, nope, not going to work. So for this, I like to use just small, simple numbers to see if it really works. So for this 2 over a plus b, I'm going to plug in numbers for a and b. I'm just going to use small, easy numbers. 1 is pretty good. So I have 2 over 1 plus 1. So if I added 1 plus 1, that gives me 2. I can reduce that to 1. So if those two expressions are equal, when I do this, 2 over a plus 2 over b, I should get 1 for my answer as well. So I'll plug in the same numbers for a and the same numbers for b and simplify. So I have that, plug in 1 for a and b. 2 over 1 plus 2 over 1 equals 2 plus 2, which is 4. So no, does not work. I have my counterexample, totally disproves the claim. 1 is not equal to 4, so these two expressions are not equal. If I have the same numerator, I cannot split them into two different fractions with the same numerator. It only works for the denominator. And then for number 4, can an exponent be distributed over addition? In other words, is the quantity a plus b squared equivalent to a squared plus b squared? And this is such a common mistake that I see so many students making. So we're going to provide a counterexample to show that they're not equivalent. So first and foremost, you can't do that. Don't ever attempt it. It does not work. And this is why. So if I plugged in just random numbers for a and b, I'm going to use 3 and 5. So I've got 3 plus 5 squared. Let's just start with adding 3 and 5 together. I get 8. 8 squared is 64. Now, I'll use that same expression. This time I'll distribute the squared to the 3 and to the 5. So 3 squared plus 5 squared, 16 plus 25 equals 41. Definitely not equivalent, so you cannot do that. The way you solve this is you have a plus b squared can be written as a plus b times a plus b. And then the next little part here, operations can undo each other like multiplication and division. Those are called inverse operations. Addition and subtraction, another pair of inverse operations, just like squares and square roots, all of that. Understanding the process needed to undo a set of operations is necessary when you begin solving equations later in this cycle. So cycle 2B, we'll be looking at how to solve equations, even though I'm sure most of you already know how to. 2B is going to be so easy for us. So just keeping it simple, not math related, sealing an envelope, mailing a piece of mail. So first step, you're going to fold the piece of paper. You're going to put the paper in the envelope, and then you're going to seal the envelope, and then you're going to mail it. And then when it gets to that person, how do they get the mail out? They do the inverse. They work backwards from the last task to the first. So we sealed the envelope last, so they need to unseal the envelope. Then take out the paper and then unfold the paper. Okay, so we're doing the inverse. We're doing the operation. We start from the last task and we go to the first task doing the opposite. Okay, so for number 5, evaluate each expression when n equals 5. And then list the operations you applied in the order that they were applied. Then provide the inverse operation to that first list. So I'm going to first plug in 5 for n. So I have 3 times 5 squared minus 1. What's my first step? I'm going to square the 5. It's order of operations. So then I get 3 times 25 minus 2. What am I going to do next? I'm going to multiply by 3. And then I get 75 minus 2. What am I going to do next? I'm going to subtract by 2. I get 75, or 73. Whew. Okay, now I'm going to do the inverse. I'm going to do the opposite. I'm going to start with the last task and go to the front. So instead of subtracting by 2, I'm going to add by 2. Instead of multiplying by 3, I'm going to divide by 3. And then instead of squaring by 5, I'm going to take the square root of 5. Those are the opposite or the inverse operations. And then we'll do one more. Again, we're going to plug in 5. What's my first step? I'm going to do everything inside the parentheses. So I'm going to subtract by 1. I get 2 times 4 divided by 3. We multiply by 2. 8 divided by 3. What are we going to do? We're going to divide by 3, and you get a decimal. So the opposite or the inverse, we start with the last. We do the opposite and go to the first. So I'm going to multiply by 3. Then I'm going to divide by 2. And then I'm going to add 1. Okay, and that concludes all of the notes for this section. Make sure that you do the homework section. There's just a couple. They should go really fast. And then we'll get ready for the summative.